Okay, welcome to Barker's recording studio. Let's get started with our notes today. Today we're going to do solving variables on both sides of the equation. Just like always, we're going to use the mantra, do the opposite. And you should be saying that every single question, do the opposite and keep it equal. Okay, so do the opposite, keep it equal. That's going to solve all our questions for us today as well. Now today we'll start showing slightly less work, but you will see enough work, okay? You'll see enough work so you can see exactly what happened between each line of work, okay? So let's get started. I'll show you what I mean by that. 4x minus 6 equals 14. Go ahead and solve that. And you would solve that by doing the opposite of minus 6. Okay, notice that that subtraction sign is in front of the 6, and that's why we do the addition. The left side cancels out, and we're left with 4x by itself, and 4x equals 20. Then, what do we have to do? We have to do the opposite of timesing by 4, so we divide both sides by 4. And we're left with x equals, these guys cancel, x equals 5. So that's just a quick little review of what we've done so far. And we're going to do the exact same stuff. We're not going to get easier. We're just going to have some more fluff before we actually get a chance to move things around and solve. Question number 2. How do we move the 3? Well, what do you see? You don't see a minus 3. This negative sign belongs with the 2x. You have to look in front. So in front of the 3, since it's not written, it is a plus sign. So to move the 3, you subtract. So you have to minus 3 from both sides. Never look behind, always look in front to decide what to do. The negative 2x is not changed at all, so it stays the same. Again, don't look at the negative sign because it belongs with the 2x. It does not belong with the 3. 19 minus 3, that becomes 16. Now what do we divide by? Well, we have negative 2 times x, so we divide by negative 2. A little bit different here. We're trying to force you to think a little bit more with the negative sign, but it's belonging to the 2, so we divide by negative 2, and so x equals now negative 8. There you go. With this one, you really want to make sure you know how to move the 3 by looking in front of the 3 to decide what the math operation is, and then you'll know what the opposite math operation is. Next question. So now it's a little bit different. So now what we have to do is collect like terms first. So we saw a few of those yesterday, or Friday rather. So we get negative x plus 5 equals negative 1. This is another great question. How do we move the 5? Well, it's a plus in front of it, so we minus 5 both sides. Now what are we left with? Okay, equal signs always line up. Notice how they are, lining up vertically. And what are we left with? We're left with a negative x. I didn't do anything to change that negative sign, so make sure you keep it with the x. And that equals negative 6. Now the question is, how do I get rid of that negative sign? Well, you have to remember that this actually is negative 1 times x. So what's the opposite of timesing by negative 1? You're right, dividing by negative 1. So it doesn't happen by magic. It happens because you're dividing by negative 1. This is super common. We see this a lot, where you get a negative x and you divide by negative 1 to the opposite of timesing by negative 1. Any questions? Make sure you ask. Email, chat, or Google me, and then we can go over things together. So today you're going to see variables on both sides. The first thing you're going to do, just like we did yesterday or the day before, is you want to, if you can, collect like terms. But when you're collecting like terms, you do each side separately. So you have a left side and you have a right side. And so when you're collecting like terms, you imagine that you don't cross the equal sign. You got to do each one separately. Super duper important. Okay. Then once you collect like terms separately, then you start moving things across the equal sign. Okay. So you have to wait until you move across the equal sign. Usually we should start with the x terms, and the general rule is it's easiest to move the smallest term. It's not mandatory, just a kind of a generalization. And you'll see sometimes you won't want to because it's too confusing. So then don't move the other one. It's okay. Then of course you can move constants. Now you can do these in opposite order. That doesn't matter. Okay, you don't always have to move x terms first. And the last step is to remove the coefficient in front of the x term. That is always, always last. Okay, just like the onion layer, peeling it off, this has to get removed at the end. So question number 1, let's get started. We have 2x and negative 5x. Which one's smaller? This one, quite a bit. So we would move that to the other side by adding 5x. And so what do you get? You get 7x minus 4 equals 17. Good. Now how do I move the minus 4? Well, I add 4. So I get 7x equals 17 plus 4, 21. Now, keep in mind, this is showing work. So what you notice is that I didn't go, oh, plus 4, plus 4. I don't do that because I don't need to do that. You're welcome to. You're totally welcome to. However, I know that I added 4. Why do I know that I added 4? It's because it's not here and those changed. This change right here and this change right here tells me that I added 4. So now for your work, you can start showing a little bit less. The blue and the red are mandatory though, okay? This is mandatory that you show that work. Don't just go right to the answer or you're going to be very confused in a few moments. Okay? Good. Next one then. 7 times x equals 21. So now I'm going to go and get the answer. I'm going to divide by 7. So x equals 3. Again, this is showing work. Why? Because I know that I divide by 7 on both sides because of how the line changed. And this is also why it's important to line this side up and this side up so it's easier to see changes. Okay? You want to make sure that they line up vertically so you can see the changes and so you can see your work. Okay, there we go. X equals 3. Make sure you line those up vertically. Next question then. So again, can we collect like terms? Everything's simplified. This side and this side as simple as it can get. Before you move across the equal sign, you want to make sure that this and this is exactly what you see. Okay? It can't be anything more complicated than that, or it's not time to move things. You'll get confused. Which one's smaller, 5x or 2x? Good, 2x. So I would minus 2x. Again, I don't look behind. This belongs with the 3. I look in front. And that's why I'm minusing 2x. And so I'm going to get 3x plus 9 equals negative 3. The 3 must stay with that negative sign because it belongs here. It can't disappear unless somehow a rule is followed. So don't just magically change things. Good, move the 9. So I add 9, so I subtract 9 to both sides. I get negative 12. And then I divide by 3, x equals negative 4. What's the work? Well, this is perfect what I just did. This is absolutely perfect. So this is showing your work. But what I did is I minus 9. And I know that from how this line changed. Okay? Then what do I do in the next line? I divide by 3 both sides. But I know that from how this line on the bottom changed. So yes, you can start showing a little bit less work. Okay. So right here, this work here, and this work here is optional. But I know students, Calculus 12, amazing, brilliant people that still show that work. Nothing wrong with it. Okay, I'm just kind of giving the lazy people that have never showed the work the okay that it's okay not to. All right, next one. It's a very typical question. So the thing that I've been saying is move the smaller one. So we would move the 4x. Now, is this a plus or a minus? Well, look in front. That is a plus 4x. So we minus 4x both sides. And this is where you guys stop following rules. You go, I don't know what to do. Freak out. Well, come on, folks. What is positive 4x minus 4x? You're right. 0. So then we get 40 plus 2x. There's nothing wrong with having that as 0. Okay. So then how do we move the 40? Well, we don't look behind the 40. We look in front. And that's a plus. So we minus 40. Okay. Minus 40 from both sides. Then you guys start freaking out again. What's 0 minus 40? Well, come on. 0 minus 40 is negative 40. Okay. Do it on your calculator if you want. I'm okay with that. Guess and check a little. So now it's an easy question. We have 2 times x, so we're going to divide by 2, and we get negative 20 equals x. So there's also an alternate way. Some of you might have noticed this. You might have thought to yourself, I get freaked out. That 0 scared me. I started crying like a little baby. So what do I do instead? Well, instead, why don't you move the 6x? And I'll show you what that looks like. I told you you could, so you can. You could decide to move this over to the other side. So I minus 6x from both sides. Now don't freak out. This is a negative 2x. There's nothing wrong with that. It's not different yet. We're not at our final answer yet. Now the cool part is that's a positive 40. So I have negative 2 times x, so I'm going to divide by negative 2, both sides, and I get positive x equals negative 20. What do you notice? Well, I notice here that this is a negative 2 and this is a positive 2. Yes. But what else do you notice? That it always works out the same answer unless you make a math error. So wherever you solve for x on the right or x on the left, it doesn't matter. You'll get the same answer unless you make a mistake. Okay? So this is a great question. I love it. A lot of times students freak out with that 0. They don't know what to do. And then you can see solving x on the right or the left, it will give you the exact same answer. Okay, let's go down. 2 more to go. Now we're going to solve and check. And you'll notice that the questions got slightly more complicated. Now we have to collect like terms. Okay, so the reason why we want to collect like terms first rather than start moving things across the equal sign is because when we start moving things individually, there's just more confusion going on, and that's when we tend to make mistakes. So a simpler way to avoid mistakes is to collect like terms first. So here we have 3x and 2x, and so that becomes 5x plus 7. Now you're welcome to write 7 plus 5x. It's exactly the same. It doesn't matter. Okay, your choice. I just like to keep it this way because I'm more used to seeing it that way. The left side doesn't change because there's no terms to collect. So then I'm going to go and I can move the 2x. So I will minus 2x. And there's my equal sign. I get 3x plus 7. What do I get on the left side? Yeah, this doesn't change. It stays as a negative 8. So again, I look in front of the 2 to decide how to move it, and it's a plus 2x, and that's why I went minus 2x. Now I'll move my 7 over because I have my 3x on the right side. I'll just take my 7, move it over, minus 7, both sides. I get negative 15 equals 3x. And I'll divide by 3. And I'll get negative 5 equals x. Good. So now what I'll do is I'll do a quick little check. So because it does say solve and check. So I substitute into the original equation. So I'm going to take my original equation right here, not the second line, but the original one, and write it again. And so I will get 2x minus 8 equals 3x plus 7 plus 2x. Okay, there we go. Okay, and so we're going to substitute in using brackets, of course. Always use brackets when you substitute in. So where my x value is, it becomes a -5, a -5, and over here too, a -5. All right, and so I'm going to get 2 times -5 minus 8. Great wall of check. 3 times -5. You don't want to move stuff across the equal sign anymore. That's why I like to do the great wall of check. So what you have on the left side is some bed mass. What you have on the right side is some bed mass. So now you're just going to solve each side separately. So -10 minus 8, -18. Over here, -15 plus 7 minus 10. So I'm just multiplying. Right, just doing a little multiplication, starting my bed mass. -15 plus 7 is going to be -8, and the minus 10 doesn't change, -18. So yes, you have to write this down. Left side equals right side. I want to see that in your work, and then give yourself a check mark. Now what does that mean? What does it mean that we have the left side equals the right side? This means that x equals -5 is correct. Okay, so if you don't get -18 equals -18, if your numbers were different, that means that you would have to go back up and fix this because you didn't get -5. You got something else. Okay, any questions? Shoot me an email or message me. Last question, here we go. Solve and check. Now this is where we're going. It looks big and ugly, but it ain't. Kind of like Mr. Barker. So simplify both sides. You don't want to change. You don't want to move stuff. It's not time for moving, and it's time to collect like terms. So put my x's together. 4 plus 1 is 5x. -2 minus 4, -6. Let's do our x's again at the front. It's always best, I find, to use this format and keep that format because it makes it simpler if you're always doing the same thing over and over. So I'm going to have a -3x. Keep that sign, it belongs with a 3, plus 6x. That gives me positive 3x. And then I have, next part is -5 minus 3, -8. There we go. Typically, we like to move the smaller one. Not a rule, just something that we find we like to do. So -3x, both sides. And we can get 8x minus 6 equals -8. Move the -6 by adding -2. Nope, that's not right. I'm making a mistake here somewhere. That's right. Here we go. So this should be here positive 2x. There we go. So this is positive 2x. And this is going to be -2. So what do we do now? Divide by positive 2. And we get x equals -1. Okay. So x equals -1. So now we have to check. Again, you don't want to check in this line or this line or this line. You check using the original, always the original. So for your check, you get 4x minus 2 plus x minus 4 equals -5 minus 3 times x minus 3 plus 6x. What do you have to do with the equal sign? Boom, great wall of check. Okay, so now what it's like you have two separate BEDMAS questions that you have to solve. So don't move things across the equal sign. That's not how you do a check. So we're going to substitute in a -1. And brackets are super important here so that you know it's a multiplication and not a subtraction. Okay, so you multiply those, -4 minus 2 minus 1 minus 4. So what I just did simply is I did this multiplication and I fixed my signs. So -4 minus 2 is -6 minus 1 minus 4, -7 minus 4, -11. Now let's get to work on the right side. You're welcome to do them at the same time. It doesn't matter. I personally like to go left side, then right side, or vice versa, rather than back and forth and confuse myself. So I substitute in -1 minus 3 plus 6 times -1. Then I'm going to do BEDMAS, so -5 plus 3. So I have to multiply these guys together, and I included that sign in front of the -3. So in front of the 3, -3 minus 6. So again, I'm multiplying this whole thing together to fix my sign as a -6. -5 plus 3 is -2. -5, -11. Again, you must write this left side equals right side. Check. What does that mean? It means that this is correct. It means that that's the answer. Okay. Now in grade 11 and 12, you get into some more complicated checks. But for us, we're just practicing our simple BEDMAS to make sure we get the right answer. Any questions? Call, text, or email. Your homework is right here. You only have to do 3 checks. Okay, not a lot, just 3 checks, 21, 23, 25. And I just do them after the question. Okay, because then you have a couple more questions because you're going all the way up to 31. Those are the nice, easy ones to check. All right, good luck, have fun, enjoy.